Okay, so this is homework 2, problem 3. So here we're given a function f prime of x, and it ends up looking something like this if you plot it. It's a cubic function. And we're asked to figure out what the original function f of x looked like. So all we can really do is get a rough sketch of what it will look like, since at this point in the class we have no way to figure out exactly what the equation of f of x is. And in fact, we'll see later that given the information in this problem, it's impossible to figure out exactly what f of x is. So the best we can do is just get an idea of what the function f should look like, and we'll try to use properties of the derivative to get some of the key properties of the original function correct. So the main ideas that we want to use are that when the derivative is negative, the original function has to be decreasing. Whenever the derivative is positive, the original function has to be increasing. So over here to the left of -3, the derivative is negative, so that means the function is decreasing. At 3, the derivative hits 0, so that means it should have a horizontal tangent line, so it sort of levels off. And then the derivative becomes positive, so it starts going up. Does something like this. And now at 1, the derivative hits 0 again, so the function again has a horizontal tangent, it starts to level off. And then between 1 and 2, the derivative becomes negative, so the function has to be decreasing. So it'll do something like this. And then once it hits 2, again, we have horizontal tangent line, then the derivative becomes positive, so the function starts increasing. So again, all I'm really looking for in this sort of problem is that you can take the key properties of the derivative with positive, negative, telling you where the original function is increasing or decreasing. So there are some things like, for example, without actually plotting what this function looks like, it might be hard to tell if maybe it decreases further, does something like that, and then comes back up. So if you plotted something like that, then that's fine, I think, for this problem, even though it turns out the actual function will look slightly more like this. But the key things you have to get are that whether f is increasing or decreasing matches the sign of the derivative.